Hi everyone, this is Mrs. Price and I'm going to be with you for all of Chapter 6. Chapter 6 is in two parts. The first half is polynomials and the second half is rational functions. We're going to start in today with our first lesson on polynomials and let's jump in. All right, so quick review of polynomials. The first type that we've got here is just that letter C in math. C normally represents the word constant, and that's exactly what we have. This is a constant function. Now, how many terms does it have? Terms are these things that are separated by plus or minus signs. So anything that's separated by a plus or a minus sign is a term. This guy right here is just one term, no plus or minus signs in there. But now the degree. Degree is a little bit, might be a little confusing for this one. So what is a degree? Degree is the highest exponent on any variable. Highest exponent on a variable. For this function, we don't even have a variable. If there's no variable, you can kind of think of it as x to the 0, because we know that x to the 0 is just the same thing as the number 1. So our degree would be 0, because the highest exponent on a variable would be 0. For this next one, we still have one term, but we have an x to the first, so our degree would be 1. And this would be a linear function because it's an equation of a line. The next one would also be linear. It's still a first degree. It's just that there are two terms. It makes it a binomial, but it's still a linear function because it has an x to the first. The highest exponent is 1. This next type, it's a trinomial, has 3 terms. The highest exponent is 2, which means the degree is 2, and it makes this function quadratic. So a function of degree 2 is quadratic. Next function has 1, 2, 3, 4 terms. The degree is 3, highest exponent is 3, and that makes this function cubic. And the last one, they keep going, but the highest one that we're going to talk about, at least today, is a 4th degree function. So our degree is 4. Let's count the terms. 1, 2, 3, 4, 5 terms. And this function is called quartic. If we went on to a 5th degree, we'd have quintic and so forth. So anyway, basic polynomials. The main thing that you need to understand from this slide is how to find the degree. So remember, the degree is the highest exponent on a variable. All right, what are polynomials and what are not polynomials? Polynomials are they're strings of terms strung together, but the x's must be raised to a non-negative integer. So the exponents on your variables have to be either a positive integer or 0 in the case of a constant. They cannot be negative and they can't be fractions. So no negative exponents and no fraction exponents. Fraction exponents include things like if I had the square root of x, because that would be x to the 1/2 power. So no negative exponents, no fraction exponents. Also, you cannot have a variable in the exponent. All exponents must be non-negative integers. Okay, and the coefficients have to be real numbers. So here we go. This first one, x to the 4th, pi x to the 3rd, -5 x squared, and 1. All of our exponents are positive integers or 0 in the case of the constant, and all of our coefficients are real numbers. Pi is a real number. Just because it's not rational doesn't make it not real. So this one, yes, this is a polynomial. Now, what type of a polynomial is it? This would be quartic because it's a 4th degree. This next one, we have a problem. We have a negative exponent on a variable, not a polynomial. This next one, 4x cubed minus 2x squared minus root 3x. Yes, this is a polynomial. Root 3 is a real number. The degree is 3, which means this function is cubic. x cubed plus 7x squared minus, 3 to the x. No, you cannot have a variable in the exponent. This last one, x cubed plus, 5 times the square root of x. You cannot have an x under a radical. Remember that root x is the same thing as x to the 1/2 power. No fraction exponents. This is not a polynomial. All right, the last thing that we are going to do today, this is our last slide, short lesson covering two sections, but a short lesson. So the last thing we're going to do today is learn how to write a function based on a graph. And when you do this, you look at the x-intercepts. So these 3 points here, here, and here, those x-intercepts, we're going to start by turning the x-intercepts into factors. So I'm going to write some steps. Write the x-intercepts as factors. All right, so our first, we're going to write y equals. Now, if our x-intercept is at negative 2.5, our factor is going to be x plus 2.5. So think of it as kind of like when we did translations, when we shifted 2.5 to the left, we did plus 2.5, very similar. Here we have positive 3.2, so our factor is going to be x minus 3.2. And the last one, we have positive 7.5, our factor is going to be x minus 7.5. Now there's one more thing we don't know, and that's if there is any kind of a dilation or scaling factor for this graph. So if we need to find a scaling factor, that's where we use the y-intercept. So use y-intercept to find the dilation factor. How do we use it? Well, remember, this is our x, this is our y, so we could just plug a 0 in for all of our x's and a 240 in for y and solve for a. So 240 equals a times 0 plus 2.5 times 0 minus 3.2 times 0 minus 7.5. If you multiply all this together, you end up getting the number 60. And so if we divide both sides by 60, we get a equals 4. So our final polynomial, I'm going to try and write this small, is 4 times x plus 2.5 times x minus 3.2 times x minus 7.5. And that's the end of today's lesson. Have a great day.